Alright, we're going to finish up 2.6, or chapter 2 by looking at section 2.6. 2.6 is about the chain rule, and there's really not a lot of material here other than just to work out a bunch of examples, okay? But here's what the chain rule says. So the chain rule says if g is differentiable at x and f is differentiable at g of x, then f of g is differentiable at x. Ooh, that's kind of weird, right? Well, here's why, right? It's because we need g to be differentiable at x, and then g of x is going to be the input for f of x, right? So we need g to be differentiable at x, and then we need f to be differentiable at g of x, okay? And if that's the case, then f of g is differentiable at x. And moreover, and this is the big deal, the derivative of f of g of x is f prime of g of x times g prime of x. So, in other words, it's the derivative of the outer function times the derivative of the inner function, which is really, really pretty nice. It didn't have to work out that way. I mean, I guess it did, right? Mathematically speaking, it has to work out that way. But not all operations have really nice properties like this. This one happens to have really nice properties. So let's just work out a bunch of examples. Okay, so let's say that y equals cosine of x cubed, and then let's calculate dy dx. Okay, so what we have to get really good at recognizing is what's the outer function, what's the inner function. In this case, the outer function is the cosine function, and then the inner function is x cubed, right? So dy dx is going to be the derivative of that outer function. So that's going to be the derivative of cosine. And if you remember from the previous section, the derivative of cosine is negative sine. So it's going to be negative sine of x cubed times the derivative of the inner function. So what's the derivative of x cubed? Well, that would be 3x squared. Right? That's that derivative. So there you go. We can clean that up and call it negative 3x squared sine x cubed. But there's the derivative of cosine x cubed. Could you imagine doing this using the limit definition of derivatives? Man, that would be quite a task. Anyway, let's look at another one. Let's do this for 4x cubed plus x squared. Okay. So in this case, the outer function is going to be x squared. Like I'm thinking of this as just something squared, right? So that's the outer function. It's x squared. And then the inner function is this 4x cubed plus x business. But we're going to differentiate the outer function first. So what's the derivative of x squared? Well, it's just 2x, right? So this is 2x. And then we're going to multiply that by the derivative of the inner function. So what's the derivative of 4x cubed plus x? Well, that's going to be 12x squared plus 1. And that's that. Okay, that's all there is to it. You can multiply that out. I'm just going to leave it as is. Excuse me. Okay, let me do another one. Okay, y equals tangent squared x. So same thing, same outer function. This is really similar to part B, because the outer function is x squared, right? In other words, another way to say this is tangent x squared, right? So it's just x squared, and then the inner function is tangent x. So dy dx. is going to be the derivative of the outer function, so that's going to be 2x times the derivative of the inner function. So what's the derivative of tangent x? It's secant squared. Right? So 2 tangent x secant squared x. Okay. Let's do one that's also similar to that, but I'll let you pause the video and see if you can work that one out. Okay, so I'm really thinking of this as x squared plus 1 to the 1/2 power. And without the chain rule, it wouldn't be possible for us to do this differentiation unless we just did the limit definition version. But this square root doesn't distribute across addition, so you can't just like say, oh, well, this is just the same thing as x plus 1 or something like that. So it causes problems. But now that we have the chain rule, this is actually pretty nice. It's not hard at all. So we take the exponent down, right? So again, I'm thinking of this as something to the 1/2 power. So you bring the exponent down and then subtract 1 from the exponent. So this is going to be 1/2 times x squared plus 1 to the 1/2 minus 1, which is negative 1/2. And then we have to multiply that by the derivative of the inner function. So what's the derivative of this inside function? Derivative of x squared is 2x, and then the derivative of 1 is just 0. So that's that. We can clean this up. The 2 will cancel the 1/2. I'm going to write this as x over square root of x squared plus 1. Okay, so this is good stuff, right? Let's do another one. Y equals sine 2x. Go ahead and give the video a pause, see if you can do that one. Okay, here's my solution. So the outer function is the sine function, and the derivative of sine is cosine. It's cosine 2x, and then we have to multiply that by the derivative of the inner function. Derivative of 2x is 2. Okay. Another one kind of similar to that. We'll do y equals tangent of x squared plus 1. Go ahead and give the video a pause, see if you can figure that one out. Okay, and here's my solution. If I can squeeze it in here. So dy dx. Outer function is tangent. The derivative of tangent is secant squared. So this is secant squared x squared plus 1. And then we need to multiply that by the derivative of the inner function. So derivative of x squared plus 1 is 2x, right? So in other words, this is 2x secant squared x squared plus 1. Okay, another one. Y equals square root of x cubed plus cosecant x. Give the video a pause, see if you can figure that one out. Okay, so I'm really thinking of it this way. So the derivative of that outside function is 1/2 times x cubed plus cosecant x to the negative 1/2. And then I have to multiply that by the derivative of the inner function, which would be 3x squared, and then minus cosecant cotangent, right? Okay, so there's that one. We can clean it up a little. I'm gonna put everything in the numerator together, so we'll have the 3x squared minus cosecant x cotangent x all in the numerator together, and in the denominator it looks like we're gonna have a 2, and then we're gonna have a square root of x cubed plus cosecant x. Okay, another one. Let's do y equals x squared minus x plus 2 to the 3/4 power. Okay, so this is going to be 3/4 times x squared minus x plus 2 to the 3/4 minus 1 is negative 1/4 times 2x minus 1, right? Derivative of the inner function. And we can simplify a little, call this 3 times 2x minus 1 over 4 times x squared minus x plus 2 to the 1/4 power. Or if you wanted to write it as the 4th root of that, you could. But there's that. Okay, so hopefully you're kind of catching on to the idea. So let me give you some more examples that are maybe a little bit more complicated. I don't know. Maybe you won't think so, but so first of all, let's say that we had like a function within a function within a function. So let's say we want to calculate f prime of x if f of x is 3 times sine squared of x cubed minus 2x. I don't know, something like that. I'm just making this up off the top of my head. But you'll notice that we have a composition of 3 functions, right? So the innermost function is this one, and then the middle function is the sine function, and then the outermost function is the square function. And it's probably easier to see that if you actually write it like this. This is 3 times sine squared, or sine of x cubed minus 2x squared, right? So it's like the outer function is the square function, and then the middle function is sine, and the innermost function is x cubed minus 2x. Well, it turns out that the chain rule still works for this, right? You just take the derivative from the outside in, okay? So in this case, we would do we would take the derivative of the outermost function first, right? Do 3 times 2 is 6. Okay, to the first power, right? 2 minus 1 is 1. And then we multiply that by the middle function, the derivative of the middle function, right? So what's the derivative of sine? Well, it's cosine, right? It's cosine. Okay. And then we multiply that by the derivative of the innermost function, which would in this case be 3x squared minus 2. Okay. And there's the answer to that. So we can simplify a little. We can maybe call this, if I distribute the 6 in here, we would have 18x squared minus 12 times sine of x cubed minus 2x times cosine of x cubed minus 2x. That's about as simple as it's going to get. Okay? Another way this could get more challenging is if you had like a product rule or a quotient rule inside of your chain rule. So for example, let's calculate d dx of sine x times sine of the square root of 1 plus cosine x. Okay, so we're going to have to do a product rule, but then for this second thing we're going to have to do a chain rule as well, and I think it's like a chain within a chain, probably. But let's see. So let's see what this is. So for the product rule, we're going to do f times g prime. So let's do the derivative of this beast. So outermost function is the sine function. Derivative of sine is cosine. And then, so that's the outermost function. And then the next function is really, so I'm kind of thinking of this as sine of 1 plus cosine x to the 1/2 power. Right, kind of along those lines. So the I guess the middle function would be something to the 1/2 power. So we're going to multiply that times 1/2 times 1 plus cosine x to the negative 1/2. And then the innermost function is the 1 plus cosine x. Derivative of 1 is 0, derivative of cosine is negative sine. Okay, so just in case you are not following along, right? So this is f, and then this whole thing is g prime. So we're not quite done, right? Because we have to do f times g prime plus g times f prime. So we still have to do the second half of that product formula. Okay, but I think it's a little bit easier because we don't have to differentiate g. Right, so we're just going to do plus g times f prime. Derivative of sine x is just cosine x. Okay, so that's that, right? The rest is simplification, which is a little nasty here. Let's see. This will give me a negative sine squared in the numerator. This stuff is also in the numerator. So I think I'm going to have negative sine squared x times cosine of the square root of 1 plus cosine x over 2 times the square root of 1 plus cosine x. Okay, so that takes care of all of this stuff. And then the second one is sine of the square root of 1 plus cosine x times cosine x. I don't think there's much chance that it's going to end up looking much more simple than that. So that's where I'm going to leave my answer on that one. Okay, and let me give you one more, and then we'll call it. Let's find d mu. So this is the Greek letter mu. I actually didn't do a very good job drawing it, but anyway, d mu over dt. If mu equals secant of the square root of omega t. So this really isn't that difficult. It's just It's just throwing some Greek letters in there. So the symbols might be a little bit like, oh, what are all these things? They're just variables. They're just Greek letters. By the end of calculus, you'll know your Greek letters pretty well, I think. So du dt. Outermost function is the secant function, so we need to take the derivative of that first. The derivative of secant is secant tangent. So this is going to be secant secant of the square root of omega t times tangent of the square root of omega t. So there's the derivative of the outermost function. And then the function that we have in the middle is this something to the 1/2 business, right? It's this something to the 1/2. So the next sort of level down would be 1/2 times omega t to the negative 1/2. And then the innermost function is this omega t. Now we're differentiating with respect to t. That means that we consider omega to be a constant. So we have omega times t to the first power, right? So we bring down the first power. Omega times 1 is omega, and then 1 minus 1 is 0. So this is just omega, right? So the derivative of the innermost function is just omega. And then, of course, we can simplify. So I'm going to put this omega out in front of my trig functions. So I've got omega times secant of square root of omega t times tangent of square root of omega t over 2 times the square root of omega t. This one comes from this. I'm just saying that because I know there are a lot of square roots of omega t going on, but this one down in the denominator comes from here. And then I think that's about as simple as that's going to get. Okay. So that's that. That's all I'm going to say about the chain rule for now. But all of these rules, chain rule, product rule, quotient rule, power rule, they're all important. They all come up all throughout the whole semester.